introduction, and welcome everybody to today's edition of Building Conversations. Very excited to have you here, and this has turned out to be a great webinar series, even if I do say so myself, on a weekly basis, with very interesting people involved in high performance housing. And today, this being June being Embodied Carbon Month at Building Conversations, today we'll be focusing on embodied carbon as well. So thank you for being here. I hope you enjoy the next 45-50 minutes. Let me move along. So today's, as I mentioned, today is or June is Embodied Carbon Month at Building Conversations, and we know that as high performance buildings become the norm, operational carbon is going to be reduced, but we cannot forget embodied carbon as we plan our build. So PHI, Passivhaus Institute, it's agnostic when it comes to building materials, and currently embodied carbon isn't part of the standards, but Passivhaus Canada is exploring how it can educate the design and construction industry and support the use of low carbon building materials, and these are all part of the discussions we're having this month. So embodied carbon is the carbon footprint of a material, and it considers how many greenhouse gases are released throughout the supply chain, and it's often measured from cradle to factory gate or cradle to construction site. But our guest today, I know, will have a more fulsome description of what embodied carbon is. So let's move along. Who am I? I'm CEO of Passivhaus Canada. Had a variety of careers in past. I've been a Minister of Environment and Climate Change. I've been a Minister of Housing. One of the most fun jobs I've ever had was a municipal councillor. I have been a business owner for many years. I have been involved with consumer advocacy, and I started out many years ago as a print journalist. And so I've had a lot of jobs in a lot of areas. My focus has always been around sustainability, around in the environment. And I know that I've been convinced that Passivhaus standards for new and retrofit buildings, it has the answers for many of our environmental and building challenges. So stay with us as we move through today's presentation. Who is Passivhaus Canada? Well, we are a membership-based not-for-profit. We're an advocacy organization. We do an awful lot of education and capacity building. We run events right across the country. We offer member and technical services. We have about 15 staff in 3 cities right now, and we have, well, we say 15 instructors here, but we actually have more than that now. Our members are primarily architects, engineers, contractors, tradespeople, government decision makers. One thing that I have learned since becoming CEO 7 months ago is that our members do more than talk. These are the people who are out there designing, building, getting their hands dirty, building high performance buildings. So when they speak, it's from a position of experience and not just theory. Today's guest is Anthony Pak. Welcome, Anthony. Anthony is the principal of Preopta, a life cycle assessment consulting firm, and one of the first in North America to offer a custom parametric LCA service for new construction projects. And Anthony is also the founder of the ECN Vancouver, the first local chapter of the Embodied Carbon Network. Anthony's a professional engineer. He has a master's in industrial ecology from the Norwegian University of Science and Technology. And I understand that is one of the leading LCA research groups in Norway. He is passionate about building awareness around embodied carbon and makes frequent presentations both locally and internationally. So welcome, Anthony. In a few minutes, I'll have him turn on his camera and we'll begin our conversation. But first this, if you've been to one of the Building Conversation webinars before, you'll know a little bit about this slide coming up. people sometimes say, although less and less, that passive house standards are a European concept. It's a ploy or a plot to sell European windows and doors into the North American market. And nothing, frankly, could be further from the truth. And I start with Exhibit A, which is Saskatchewan Conservation House. Built in 1977 by Dr. Orr and Associates, funded by the Saskatchewan government. It was built during the times of the first OPEC oil embargo, when North Americans became very nervous about how they were going to heat their homes in the wintertime. And Dr. Orr was asked, can we build a house that uses very little energy to stay warm or cool? And the answer, being a good scientist, Dr. Orr researched along with his group, the answer is yes. And not only did they do the research, they built this house, which still stands today, still being used, and it's been acknowledged by the Passive House Institute as an ancestor of today's modern passive house standards. So those of us who are Canadian and proud of passive house building can trace our roots right back to Canada. So what is a passive house? And I'm going to assume that most of you on the webinar know a fair amount about passive house, but for those who don't, there are 5 principles of passive house design. And the first principle is that the building envelope has to be super insulated. So thick walls with lots of good quality insulation. And I know Anthony will be talking to us a bit about insulation later on. Second principle is that it has to be airtight construction. We can't have air leaving or entering the building. Third principle is that it has to be thermal bridge free. We have to make sure there's no easy access for the cold or the heat to get in, or the cool or the warmth to get out. Fourth principle is that there must be high quality windows with solar orientation. So not only do we have to have good quality triple pane passive house windows, they have to be pointed in a way that maximizes the warmth that comes into the building in the cold months and minimizes the amount of heat that enters the building during the hot months. And the fifth principle is there has to be a really top-notch ventilation system with heat recovery, and it's absolutely spectacular. When you add these 5 principles together, you get a healthy, comfortable, resilient, affordable, and low energy, low operational carbon, low energy building. So Anthony, now's the time for you to turn on your camera, and we'll make ourselves known to the folks in the audience here. As soon as I can get to, there we are.
Perfect. Thanks for inviting me to this conversation.
And thank you for being here. I have to turn on too. There we are. We're here. A little bit of technical. I've only done this about, I don't know, a dozen times or more. You think I'd understand by now. But listen, thank you very much for being here and taking some time to talk to us about embodied carbon during Embodied Carbon Month at Building Conversations. Maybe you can start at the very beginning for people like me who are relatively new to high performance building, and in your words, talk to us about what embodied carbon is and why is it important that we pay attention to it.
Perfect. Yeah, great. And actually, I think that in this first part, we probably don't even need any slides. I can just kind of talk through some of these things.
Sure. And I've put a few of your slides in, so let me know when you want to move through them.
Oh, sure. Sounds good. Yeah. Well, yeah. Again, thank you for inviting me for this conversation. And you know, in my time, I've gone through passive house certified training before as well, and so like I'm connected with some of the people in this community, and I've been really impressed with how much people within this passive house community have really kind of taken up this topic. Embodied carbon, when we're talking about embodied carbon, we're really looking at the environmental impacts associated with all of the construction materials used in a building. Okay. So as you mentioned, historically, a lot of the focus has been on operational carbon, on energy efficiency, but what about what it takes to make the building in the first place? So
Right.
all the concrete, all the steel, the wood, glass, insulation, all those materials, we need to trace the environmental impacts throughout all life cycle stages. So everything from resource extraction, so kind of the mining or the process, so the resource extraction, the transportation, the manufacturing and processing, transportation to the construction site, and then if there's any emissions during the use phase, like if there's replacements, certain building components, if they have a shorter lifespan than the whole lifespan of the building, we factor that in. And then also at the end of life, so all the emissions associated with deconstructing the building, landfilling it, transporting it, or recycling it. So we're looking at all those stages for all the materials in the building. And to do that, we have to quantify those emissions. We do what's called a life cycle assessment of it, so life LCA for short. And yeah, so that's basically how we address those emissions.
Good, good. So the where do building professionals enter the equation in limiting embodied carbon, or maximizing embodied carbon, or dealing with embodied carbon? Let's say that. What's the role of folks in the building profession for that role?
Well, the building sector accounts for almost half of all the materials used on the planet, right? So if you quantify it by mass, about half of the materials that we extract from the planet, like, so anybody that's working in the building industry, we play a big role in terms of determining what type of materials to use, how those materials are produced, and then also what we specify on the projects. So architects definitely have a big role to play in that they are specifying what materials are used in the building. Same thing with structural engineers, which historically have not really been as big a part of this conversation, especially when the conversation was mostly targeted to operational carbon. Right. When it comes to embodied carbon, thinking about the foundation design, the structure of the building, how much concrete you're using, or if you're using mass timber or steel structure, there's many things that structural engineers can come into it. Building envelope as well. So if you're an envelope consultant or a Passivhaus consultant and you're looking at, in particular, the envelope aspect, there's the analysis around insulation and how that compares, or just your envelope assemblies, trying to optimize between embodied versus operational carbon there as well. So designers play a big role in all of those stages.
In all of those things, yeah. So I've heard you speak about the blind spots, the problems worth solving. And I know that's one of the slides we've included here, but talk to us about what are some of those blind spots?
Yeah, perfect. Yeah, so if you pull up that slide, I think last year when I wrote my first and probably only article so far, I titled it as Embodied Carbon, the Blind Spot of the Building Industry. And it really has been a blind spot for a long time. I know for a while there that there definitely have been certain people within the building industry that has, focused on embodied carbon, but it's been a relatively kind of ignored or neglected area. And only now do we start to see it actually being addressed on more construction projects. So the first blind spot is the field of embodied carbon itself, right? As we talked about earlier, most of the focus has been on operational carbon. We haven't looked at embodied carbon as much, which makes up about 11% of global annual CO2 emissions. But even within the topic of embodied carbon, I think there are multiple blind spots within there. There are blind spots within the blind spot. And so in this graphic, what I'm showing here is that when you're thinking about what problems are worth solving, you want to find a problem that's really big, like that has big consequences, or in our case, like big amount of carbon emissions associated with it, and that it's solvable. So it's something that we can do something about. We have strategies for dealing with it or addressing or reducing those emissions. And then it's also ignored. And that ignored piece is a big deal because as much as we've had a ton of focus on operational carbon, which is super important, I think because this field has been this topic has been so neglected, there's a ton of opportunity. There's a lot of emission reduction potential there. So some of those subtopics that I mentioned there is within embodied carbon, we've definitely within certain types of insulation, I think we've underestimated how significant those emissions are. So I have a slide later where we'll talk a bit about that, in particular with XPS and spray foam insulation. Refrigerants, when we're doing, actually, let me back up a bit. When we're doing a life cycle assessment, typically on a lot of the projects right now, we're mainly focusing on the building structure and the building envelope. But we're not looking at, for instance, the interiors. We're not looking at mechanical systems or refrigerants. So those are some additional components that we're even not fully including in most of our analysis right now. So yeah, and then forestry is another area, growth and floor area. So we can talk a bit more about that, but yeah, there's lots of blind spots.
Yeah, and I know, I mean, you know, coming from a passive house background, I look at insulation and I shudder a little bit because we love insulation. And I know how particular we have to be when we're, and you well know this, having been through and being certified, you know, some of the buildings where we have to run around and count up how many kettles, how many toaster ovens, et cetera, so that we get a good understanding of operational carbon of that building. And so now what we have to do is we have to look at both those operational energy uses so that we can work that into our calculations. And now we have to address operational carbon as well. And that, as you mentioned earlier on, the structural engineers play a central role in that. Okay, so do you want me to go on to the next slide then?
Sure.
Okay, so this is one about concrete mixes.
Yeah, so there's obviously been a lot of attention on concrete lately, especially as this conversation around embodied carbon has ramped up. And so this slide is really to show that even within concrete, there's a lot that we can do to reduce emissions. So this graphic is pulling from the Canadian Ready Mix Concrete Association. So this is the industry average EPD, so environmental product declaration for concrete mixes, which is essentially looking at, you know, per meter cubed of concrete, what's the carbon emissions associated with various different mixes. So for 35 MPa strength concrete, so keeping the strength the same, you can see that there's a big range in emissions. And so compared to the industry average benchmark, if you go to like the max scenario, you can get 35–40% reduction per unit of concrete. So for the same strength to hit that. So it's there's quite a bit that can be done. And so when we're looking at how to reduce the embodied carbon of a building, and concrete makes up a significant chunk of those embodied carbon emissions, we need to think about how do we optimize the concrete mixes for each element of the building, from like the foundation all the way to you know, your walls and your floor slabs and your roof. Yeah. So this is more just to highlight the mitigation potential there.
So it's about you know, architects working with structural engineers to minimize the amount of concrete and steel they need, to only use what they really need, and to pick the right concrete, to pick a concrete that has the lowest possible carbon footprint. Yeah,
exactly. And so, for instance, in this graphic, you'll notice that some of those rows say GU and some of them say GUL. So GU refers to regular Portland cement, general use Portland cement, and GUL is general use limestone or Portland limestone cement. So essentially they're adding a bit more limestone and displacing some of the cement that's used in the concrete, and cement is where most of the emissions come from within concrete. And so GUL is kind of one of those like low hanging fruits that it leads to roughly about a 10% reduction in embodied carbon. And it's something that you can do right away. There's not any major performance trade-offs or whatnot. But it's still not common practice. You know, oftentimes it's like people aren't specifying or so there's a lot of these, because we haven't focused on it, nobody's really looked at these numbers, or it wasn't part of the equation. We haven't addressed it, but there are many examples of these sort of low-hanging fruits.
So when it comes to concrete, it's not that we have to wait for the holy grail of a new concrete invention, a new type of concrete. There are readily available concretes today that a structural engineer could specify in order to reduce the carbon footprint of the building.
Exactly.
Yeah. Okay. That's quite interesting. And I know in a previous career, a number of conversations with the National Concrete Organization about research and the testing for new types of concrete yet to hit the market in a big way that are going to make these numbers even better. So
exactly.
I see our next slide. That always makes me nervous being a passive house guy. The next slide is about insulation.
Yes.
Talk to us about insulation.
Yeah. So in this slide, what I'm showing is many different types of insulation. So most of the top half of that table is focused on XPS insulation and also spray foam insulation. And then all the kind of grayed out text, those are other forms of insulation. So like EPS, GPS, polyiso, mineral wool, cellulose. So you can see for most of those grayed out results at the bottom, they're relatively lower compared to the results on the top half of the chart. And the way I've organized this is going from R5 to R60 insulation.
Okay.
And one of the key, this is something that I've actually spent a few months kind of looking into. And it's because I believe that XPS and spray foam insulation in particular have been significantly underestimated in our life cycle assessment calculations. So in the main software tools that are used to do a whole building life cycle assessment, so Athena, Tally, and One-Click LCA.
Right.
Those tools, you can specify XPS in there, and depending on the tool, they may have some generic industry average entry for XPS. Or in the case of One-Click LCA, they actually have manufacturer-specific EPDs from like Dow or Owens Corning.
Right.
But what I've seen is that those numbers are quite low compared to the actual numbers that you just see straight from the EPD from the manufacturers. And so the numbers that I'm showing here are the numbers from Dow and Owens Corning straight from the manufacturer. And there's about a 10x difference in terms of the emissions. So this has huge implications in terms of our embodied carbon analysis, and also on many of the previous case studies that we've done on LCAs is because if in our tools, if the underlying data doesn't fully account for it, then obviously it's going to get reflected in the whole building calculations. And so in particular, the reason why it's so bad, or why these emissions are so significant, is because of the blowing agent. And that's why in particular for XPS and for spray foam. So they both use what's called HFs, or hydrofluorocarbons, HFC, as a blowing agent, which is essentially refrigerants.
Right.
And so these gases, small releases of these gases, have a very significant impact on climate change because they're thousands of times worse than CO2 per unit.
Right.
And so what was not fully reflected in the past was the emissions that happen during the operation phase of a building. If you think about most materials, there's not many emissions happening during the use phase of the building because it's sort of an inert material. It's not off-gassing or whatnot. But in the case of these blowing agents in the insulation, in these EPDs, they assume that it does get released throughout the lifespan of the building and also during end of life. And so when you account for those carbon emissions, it's hugely significant. And another factor why there was such a big discrepancy was in Europe, they've banned these HFCs for a long time. And so the XPS there is very different than the XPS in North America. And in North America, we've the only type of XPS that you can buy is this type that has HFCs. But the one thing I do want to mention, which is a huge win, is actually there's new regulation that's coming into play. So at the end of this year, or by the beginning of next year, January 1st, 2021, Canada has actually banned these types of HFCs in the insulation. That means that all the manufacturers have to kind of come to market with new XPS and new spray foam. And so this is something that the design communities should be aware of. And I think this is actually a huge win from a regulatory standpoint, because kind of hearing some of the background story from Owens Corning and kind of from a manufacturer perspective, what happened back then was that in 2015 there was this ban on these HFCs, or like they were thinking about implementing this. So Canada stuck with the original schedule, but on the federal level at the US, they basically scrapped their plans, which was from the EPA. And so then individual states started trying to implement this type of regulation, and so it kind of created a whole bit of confusion. But basically, from a manufacturer standpoint, it was because Canada's regulation pushed this through that it actually had those manufacturers adapt their processes. So I think it's actually a big win to show like how important it is with with having the right types of policies in play.
Yeah, it's very important to have national government pushing the right regulations. You know, then it's not a hodgepodge of provinces, or in the American perspective, a variety of different states doing different things.
Exactly. And actually, I'll just say one more thing about this is that to give you some context for these numbers, because I mean, these numbers may not seem very meaningful, but if you think about a typical whole building LCA study, the range of results that we're getting, the range is anywhere from 100 to 1,000 kilograms of CO2 per meter squared of floor area. And typically most of the projects are, let's say, in the 200 to 600 range.
Okay.
But if you look at this case, like if you go to R60, so 12 inches of XPS insulation can be by itself 1,000 kilograms of CO2 per meter squared. Of wherever envelope area that you're covering with that insulation. So it gives you a sense of how significant the underestimation has been. And that's why I'm pointing to this, is that it will be a big factor. So they're going to be transitioning to more HFO blowing agents. So you can see that I've highlighted this Jackson EPD from Germany, which uses HFOs, and it's about 1/5 of the impact, or less than 1/5 of the impact compared to the conventional. So we haven't seen what the North American manufacturers, what their EPDs are. They haven't released that data yet, but it should be significantly lower. But it's just something to keep in mind, is that that's obviously going to change our calculus in the nexus between operational and embodied, and where the trade-offs are.
Absolutely. And I know with regards to the Passivhaus world, there is some practitioners who aren't happy with or are recommending against, except where absolutely necessary, the use of expanding foams, because they're finding after a few years cavities, small cracks are appearing between the foam and the wood, allowing air leakage. And we know in a Passivhaus, air leakage is one of those fundamental fives that I mentioned early on, that we can't have any. So I think we're seeing those limited more and more, not only because of embodied carbon, but because of long-term performance issues. Maybe with the reformulated products that are coming out, that will change. I guess we'll have to see as we go down the road.
Totally.
So that's good. So I've got another slide here, policies and standards at different scales. Can I move to that one?
Sure, yeah.
Okay, so talk to us about these policies and standards.
So why address embodied carbon, right? Or what are the drivers that are addressing it? And so there's things like voluntary standards, so things like LEED or CAGBC's Zero Carbon Building Standard, or the Living Futures Institute. Like, they have a few programs that focus on this. So I've kind of grouped this. I've kind of labeled a few of these policies or programs that are addressing it at a whole building basis. So looking at the whole building, and they may, for instance, specify that you need to do a whole building life cycle assessment for your building, and then demonstrate some level of reduction, so some percentage reduction relative to an equivalent baseline building. And then there are some policies that are targeting at individual materials. So maybe it's something specifically focused on concrete or a few key material items. And in that case, they're looking for EPDs, so environmental product declarations from the manufacturer, and they may have some threshold, maybe a max allowable limit, or maybe some performance benefit relative to some benchmark. So this is just to illustrate that there are policies that are kind of targeting at both levels. And actually, was it yesterday or the day before, there was an amazing document that was released, or a big report to support policymakers, because this is actually a big question for many different cities, different municipalities, on how to address embodied carbon. And so this report from One Click LCA and Architecture 2030 and Carbon Neutral Cities Alliance, they compiled 52 different policies and looked at, evaluated what's the carbon reduction potential, what's the efficacy, cost effectiveness, a few different metrics. And they actually have example policy language that people can use to adapt to. So I think that's a hugely valuable resource for if anybody's kind of talking to decision makers or policymakers, or they are policymakers themselves at a city level.
Excellent, and that's a great document. Can you take a couple of minutes? And I know, there seems to be you know, we have choices of materials we can use in the structure of the building, the finish of the building. Talk to us. You spent some time talking about concrete, but talk to us about concrete, steel, wood. You know, is one clearly better? What are some of the pros and cons of each of those materials?
Well, first off, I think in a typical building, you're using combinations of multiple materials. So it's not just like one versus the other. And I think sometimes that's
that's unfortunately how it's presented sometimes. That,
it is.
you know,
It is.
that one is one is inherently evil, so you should not use it. But you have to, most buildings you use all three.
Yeah, and you need to, and there's a lot more of a nuanced conversation. So I don't think it's actually that productive. Like you can have wood buildings that are like very high emission intensity. You can have like concrete buildings that are very low emission intensity, or vice versa. I wouldn't categorize it that way. I would look at, for the given structure, like what are the design strategies that you can use? Like how can you make it more materially efficient from a structural perspective, like your column spacing, or like, you know, how you're designing your loading or whatever. There's so much that you can do there. And then how do you select the right materials within there? I would say that, like, yeah, when you're looking at kind of these aggregate studies, typically you see from these whole building LCA calculations that the wood buildings do come out relatively lower compared to like the concrete and steel buildings. However, I would say that in the wood sector, when we're talking about biogenic carbon, that's a very complicated topic, and
Right.
Because then that involves things like what happens in the forestry level, how do we address those issues, and so that's one of those blind spots that I would say. And actually, if people are interested in learning more about that topic with biogenic carbon, there's a few good resources out there. The Tallwood Design Institute created a great primer on this. And then also the Carbon Leadership Forum, they've had a series of these wood carbon seminars recently that's still ongoing, and those I found very illuminating. They have like top people from the North American kind of forestry sector or involved in the LCA side to help us really understand these different factors more.
Right, right, okay. Because you just touched on a question I have for you. For building designers, can you give us one or two great resources that that they can utilize, that they can do some further research on, maybe when it comes to building materials?
Great resource. I'm trying to think of like, there's been a few, like maybe the thing that I can point everyone to is like, I've put a lot of effort into compiling slides with like references to everything. So if you actually go to my website, Priopta, or our website, priopta.com, you scroll to the bottom, you can download a copy of that slide. It's like 100 slides, and each slide has links to different topics. So if you're interested in concrete, you're interested in wood or whatever, just like click on those links, and then it'll take you to the original sources.
Okay, excellent.
One good example is, actually, I'll just leave it at that. I think that's.
I should preface my question by saying, outside of calling Anthony, you know, what other expert advice can you give us? And I've seen, I mean, you have a very extensive presentation. Your standard presentation is very extensive. We've only been through 4 of many of the slides, and there's lots of information there. So you know, we're running into question time. But what else do we need to know? And actually, I had a question before we get there. So a number of the people on our webinar are architects or engineers, and are probably up on a lot of the things we've been talking about. But I always know we have a few people, a few environmentalists, and some just generally interested public members, some householders, people looking to build buildings. What advice would you give, you know, the regular public or someone who wants to build themselves a house? They're maybe not going to have the budget to hire an expert to do that full life cycle assessment. But what could someone do who's looking to build something? What are some of the key questions they need to ask?
Key questions. So first off, I think there is a lack of these like guidelines or resources to support, especially people that are kind of early stage into this. Like we should come up with some better best practice guidelines.
Okay.
But that said, I like focusing on the key materials. So like concrete, like I mentioned earlier, like looking at those mixes. Looking at insulation can be a big area as well, with that kind of chart that I showed. I wish I had a better answer. I mean, I think what we need to do is actually come up with good resources for different
Right.
building archetypes and run through a lot of scenarios, and then actually present this to the public and make it widely available. So you don't need to do a custom analysis for each project, but you
Yeah.
can kind of get the high level guidance, or getting a kind of, I think one of the things that's missing in the industry right now is that people don't have an intuitive feel. Even people at like the biggest architecture firms or the biggest design firms, like they don't have an intuitive feel for the embodied carbon impacts. While we've developed a lot of this on the operational side, we're like, that's a big piece that's missing. And so we actually need to do these more comprehensive studies, at least, or see reports of this to
Right.
be able to understand what's the relative scale of things.
Yeah, yeah. And I know, and it's not necessarily just embodied carbon, but you know, when I talk to people, I ask them, you know, do you have to build new? Can you repurpose the building on the property? Does it have to be as big as your building? You know, do you have to build a building as large as you want to? So it's that footprint creep that you talked about early on. Some of those really simple things that people need to ask themselves. Can they repurpose the building that's there already? Can they just, is it a Passivhaus Interfit rather than a tear down and rebuild? Those are some simple things that you know aren't necessarily an embodied carbon answer, but certainly go a long way to affecting the environmental, the carbon footprint of anything they're doing on those sites. So
I think that's actually that's a better answer. So I would say I 100% agree with that. And the other thing is, like, consider looking at your metrics. Instead of kilogram of CO2 per meter squared, think about per occupant, which basically puts you to that point of like, how space efficient are you with this?
Right.
Like in the States, I think they have maybe double the residential floor area per capita compared to the UK, right? Similar GDP levels, but like, so that's something to really focus on, is how do we make more effective use, and also how do we make those spaces more adaptable to future use? Like we're probably going to have a bunch of empty like malls and retail stores. Like, what do we do with that floor area? Can we make better use of that space? How do we make sure that these spaces are kind of designed to be adaptable for future uses?
So density is king,
Yeah.
or queen. Very good. So why don't we, any other final comments before we go to questions, Anthony? I'm assuming there are some questions, Stephanie, but Anthony, what else do you need us to hear today?
Well, I think the key thing is to really, we need people to champion this. So this, like, it doesn't do any good if it's just me that's gonna, or like, do you know what I mean? Like,
yeah,
everybody that's in the industry, you're connected to like project teams, colleagues, and the more we can kind of spread this word and to build this awareness and learn together, the faster we can move. And that's what we need, is like, we need the whole industry to move really quickly. I think a really great way of starting that is to engage with the Carbon Leadership Forum, which is formerly called the Embodied Carbon Network. Actually, did you say you have a slide on that? Maybe I can just do a quick plug on that piece, or maybe I do that at the end.
Well, there we are. There's the slide. I can always go backwards.
Sure.
I'm going to ask you to talk to us about ECN Vancouver, and I know Passivhaus Canada, we're involved with the international embodied carbon network. So you're right. We are going to be getting more involved. We are going to, and we are already taking this message about the importance of embodied carbon to the government decision makers, to our contacts in business and industry, so that they begin to understand that this is an area, as I said at the very beginning, as we drive down operational carbon, more and more government attention is being paid to embodied carbon. So it's smart for all of us to get ahead of what's coming down the pike, we'll say, and prepare for new regulations when it comes to embodied carbon. That's, from a Passivhaus Canada perspective, one of the key reasons we're getting involved is to make sure that our members know what's coming. But you wanted to talk a little about ECN Vancouver, Anthony, and I cut you off.
Yeah, no, that's a great point. So first off, Embodied Carbon Network is actually getting rebranded. We're kind of in a bit of a brand transition. So even ECN Vancouver is going to soon be called CLF Vancouver, Carbon Leadership Forum Vancouver. And that's kind of aligned with sort of the parent group that helped create the Embodied Carbon Network and reduce the confusion. But since we've started that chapter like a year ago, now there's 20 something cities around the world that are like taking this up. And so what I would say is that like from what I've seen, even in Vancouver, is that like creating a local group, bringing together the local industry practitioners, all the people that should be part of the conversation, architects, structural engineers, concrete industry, wood industry, policymakers, like all the relevant people. You need to kind of bring them together and start like tackling these different topics and learning together and building up awareness. So I think that's one piece. And then the other thing is further to that, there's an online discussion board from the Carbon Leadership Forum. So the Carbon Leadership Forum CLF community. Yeah. And so when you join Carbon Leadership Forum, I think it's carbonleadershipforum.org, you go to the website, you join it. You can join this platform where there's, I think, 1,000 to 2,000 professionals there that are just talking about or sharing about the best resources on embodied carbon, and just there's active discussions there every single day. So I think that's a great way of actually educating and learning yourself. So I would highly recommend that as a next action.
And I enjoy scrolling through the questions and the answers and the conversations that are going on that website. It certainly has taught me an awful lot. So that's good. But for folks interested in joining ECN Vancouver, soon to be rebranded, but they can start by going to ecnvancouver.com and signing up for the newsletter and learning about workshops that are happening. So we'll go back here, and if I can call upon Stephanie. Stephanie, do we have questions for Anthony?
That was a very interesting conversation, Anthony, and there are lots of questions. We may not get to, we probably won't get to all of them, but we'll see how we can do. The first question is, do the concrete mixes with less embodied carbon typically cost more, and are they easy to source?
I guess it depends on, first off, the sourcing, I'm not entirely sure. It depends on probably where you're located, but in, like for instance, in Vancouver, they're readily available, and in some cases common practices as well. So like for instance, the Portland limestone cement, GUL, my understanding is that like a lot of the Metro Vancouver supply, or at least in Vancouver proper, like that is common practice there. Is it more expensive? I think on the material basis, it could actually be less expensive because cement is actually where is more expensive. So using the fly ash or the slag to kind of displace some of it is relatively lower cost. Where it might affect things is the construction scheduling. So sometimes when you're increasing the amount of fly ash or slag in your concrete, that might change how long it takes your concrete to cure. And so depending on which building element you're talking about, it may kind of be the limiting factor in your construction scheduling. So that's just something that you got to work through with your structural engineers to kind of think through. There may be certain elements of your building where it makes sense, where you can really boost that amount of SEM content. So for instance, in your foundation, but maybe in your above grade floor slabs, you can't afford to go as high. So that's some of the things that I see, but just try to figure out how you can maximize it by building element.
Yeah. Great. Okay, the next question is, Builders for Climate Action will be releasing a beta version of software this summer to help elevate embodied carbon for building materials that can be used in residential construction. Are there other software programs that calculate embodied carbon for Part 3 and 9 buildings to help us with material selection?
So there's the Athena Impact Estimator is a free tool that you can use to do whole building LCA. So I think that's a great starting point because it's freely available. It's quite versatile actually. You can build up many different kind of wall assemblies or configurations for your building using kind of simple area takeoffs from your PDF drawings, for example. So I think that's a great starting point. There's Tally, which is like a Revit plugin, and then there's One-Click LCA, which also integrates with Revit, but can kind of do some of the early analysis as well. So those are kind of the three main tools to do these whole building LCA calculations. And then there's also this EC3 tool, which has come out, but that's more for procurement decisions. So it's not a whole building LCA tool by itself. It actually has a connection with Tally. So like you can kind of use it during at later stages in design when you're trying to compare between different manufacturers. But I would say, like, if you're talking about just a low-rise, small-scale residential, something like Athena is a great tool to be using for that as well, or a great starting point.
Great. How close to product introduction are the upcoming types of concrete that significantly reduce embodied GHG content?
So, I mean, I think these concrete mixes are readily available right now. So they're, in terms of using Portland limestone cement, I think that's quite commonly available, my understanding at least. And then the supplementary cementatious materials, so like fly ash, just like you can easily kind of change the concrete mixes there. It's more just what concrete mix you're asking for there. There are some emerging technologies, things like carbon cure or other kind of more, and even stuff that's more on the R&D scale, like the research and development scale, that haven't fully come to market yet. But I think the things that I showed you in that slide, that's readily available. You can create that, like you can use that right now. It's just a matter of specifying.
Great. Do you have a GWP for straw bale walls?
No. That's a good question though. I mean, I think these rapidly renewable materials, there's a lot of potential there and a lot of interest as well. I'm not sure that I've seen any EPDs. And to do an EPD, basically, they need to kind of commission a life cycle assessment for that whole process. And I think, yeah, so we haven't seen as much of that, those EPDs be available for some of these more emerging products, or yeah.
Great, okay. Next question is, how does rock wool insulation compare to XTPS?
XTPS? I'm not sure what XTPS is, but I think in that previous slide, and we'll probably send out those links later on. I think you can kind of look through that. Did we have rock wool in there? I can't remember if I actually have it in there. Anyways, just off the top of my head, I don't remember. But if you're referring to XPS, XPS is probably the highest impact one out of all of them,
okay,
by far.
That may have just been a typo.
Yeah. Okay. Yeah.
Where does high fly ash concrete sit on that concrete chart?
So if you go back to the concrete chart, so you can see that you see that percentage figure, those ranges like 15 to 29% FA or 25 to 34% SE. FA stands for fly ash and SE is slag. So they just kind of alternate back and forth between them, but you can basically, that's showing you the percentage of fly ash or slag used in the concrete mix. So as you go further down, as you get to higher percentages like 35 to 50%, you can see there's corresponding like more percentage reduction per unit of concrete.
Great. Have you looked at carbon impact of autoclaved aerated concrete? By weight, it might be as bad as other concrete products, but since it is 70 to 80% air, its actual impact may be low. Do you have a comment on that?
I think that's an interesting, I haven't looked at it specifically, so I can look through the databases, but, and so, yeah, so I would say I just haven't seen it, or I haven't looked through it in particular myself. However, depending on the tool, it also impacts what type of materials you can look at, because they draw on different underlying databases. So something like Athena may not have, probably doesn't have that as a material entry. But if there has been a manufacturer-specific EPD that's been published on AAC, yeah, then that can be integrated into something like one-click LCA or EC3. So then from there, you can kind of do more of a comparison. But I haven't actually searched, I haven't seen it myself.
Okay, I'll give you one more question, and I think that's probably our time. Is wood fiber insulation being used in Canada, and how popular is it, and what implications does this have on LCA?
Wood fiber insulation, so is that maybe like Gutex, I guess, or if I understand correctly, but I'm not sure how common it is, so I'm not familiar on that front. The wood fiber, I did previously try to search for the Gutex does have an EPD, and but I think it's a European EPD, so I'm not sure if it's directly comparable, but generally speaking, those numbers are relatively low. I don't have the specific number off the top of my head, but yeah.
Okay, and that's, I think, the time we have left.
Good. Well, listen, Anthony, we could probably go on for, judging by the questions and the interest and how deep this topic is, we could perhaps carry on for another hour, but our time has come to an end for this time. And I would encourage everyone to do two things. visit Anthony's website and download his very extensive deck with all the slides on it. It's good reading. It's very interesting reading. Certainly consider joining ECN Vancouver so that you can follow along, and the international organization's chat room is worth visiting as well and joining for that reason. So I will thank you, Anthony, for joining us during Carbon Month here at Building Conversations, and wish you all the luck. I know we will be in contact as Passivhaus Canada works to include knowledge about good building choices, good material choices with our members and with government decision makers going forward. So thank you for today. And as they say, we'll be in touch. Take care.
Thank you so much. Thanks for having me.
Great, great. Our pleasure. Let me turn off, we'll turn off our cameras now and just finish up. I mentioned I encouraged everyone to join ECN Vancouver. And given Passivhaus Canada's focus on embodied carbon, I just wanted to let folks know that we are launching a Passivhaus Canada training program to identify and drive down embodied carbon in buildings. It's a fairly, it's a good introduction with a good technical side to it, but it's our first kick at working with the Embodied Carbon Network to get out to building designers and product specifiers about how to make the right choices. So this deck is included, this slide is included in the deck that you'll see attached to today's presentation. So consider learning more at our website. Next week, I will say I've got a really great special guest, Chris Magwood, who is the Executive Director of the Endeavour Centre here in Ontario, will be our guest. Chris brings quite an interesting history and expertise. One of the busiest folks you'll meet in the whole embodied carbon world. And I really look forward to meeting with Chris and having a conversation and learning more about the importance of embodied carbon. So I will leave today's Building Conversations there. Thank everybody for joining us, and please look to join us for next week with Chris Magwood and our continuing journey into the world of embodied carbon. So thank you very much, everybody. Have a great rest of the day and a safe week until we meet again. Take care.